Mr. Tarrou, so we have defined inequalities and looked at their graphs on a number line and talked a little bit about compound inequalities as far as graphing them. We just got done with our Algebra 1 lessons looking at solving inequalities with addition or subtraction, basically one-step processes. And now, we're going to be solving inequalities using multiplication or division. And then in our next lesson, we're going to be looking at solving multi-step inequalities. Now, I mentioned this in my last lesson, but the reason why we separate the multiplication and division away from the addition and subtraction process for solving inequalities, they're both one-step processes, but when you multiply or divide by a negative number, you're going to have to remember to change the sign, and thus we want to just make sure we hammer that down early in our algebra study so you remember it later. We're going to do 4 examples, by the way, and the last one will be a 5th example, a word problem. So we're going to let A, B, and C be real numbers with C is greater than 0. And if you have A is greater than B, then when you multiply both sides of that inequality, the inequality is not going to change direction. We're going to have A times C is going to be greater than B times C. And if A is less than B, then A times C is going to be less than B times C. So when we multiply both sides of our inequality by a positive value, the direction of that inequality or that inequality relationship is going to stay the same. It's just going to basically kind of become more extreme. So when we're looking at -1 is less than 2, so here's -1 and here's +2, smaller on the left, bigger on the right. We multiply both of those values just by an example. We're going to let C equal 3, and we get -3 and is going to be less than 6. We're basically, let's see, we're going to have, instead of one movement to the left of 1, we're going to move 1 unit to the left 3 times. So 1, 2, 3, and we're at -3. And instead of moving to the right 2 times, instead of moving to the right 2 units, we're going to move to the right 2 units 3 times. So from 0, we're at 1, 2, and 3. So by multiplying by this positive value of C, we're moving farther away from 0 on the number line, and we keep that inequality going in the same direction. If, though, C ends up being negative, less than 0, a negative value, then if A is greater than B, then A times C, B times C, notice that we've multiplied both sides of the inequality by a negative number, and the sign has to change direction. And if A is less than B, then AC is going to be greater than BC. And so our example here, going back to the fact that -1 is less than +2, so in orange we have -1 and +2 marked on our number line. If we take -1, which is a movement to the left 1 space from 0, and multiply it by -3, that negative sign changes the direction. So instead of moving to the left 1, we're going to move to the right 1 3 times, and we're going to end up with 1 starting at 0, 1, 2, and be over at +3. So -1 times -3 is +3. When we take 2 and multiply it by -3, well, 2, a +2, is a movement from 0, 2 units to the right, but instead of moving 2 units to the right, we're going to go in the opposite direction and move that 3 times. So we're at 0, 1, 2, 3, and we're at -6. Well, we started off with the smaller of the two numbers, -1 being on the left, but after multiplying by that -3, now 3 is on the number line to the right of -6, so 3 is actually larger. So when you have, when you're solving inequalities, when you multiply or divide both sides of the inequality by a negative number, you are going to change the direction of that sign. And we say multiplication and division like it's two separate things, but you know, dividing by 2, like 10 divided by 2 is 5, well, I mean, I could multiply by 1/2. Dividing by 2 is effectively the same thing as multiplying by 1/2, and 10 times 1/2 is also equal to 5. So that's why the rules are the same for multiplication and division. Multiply or divide by a negative number, you're kind of saying the same thing. If you're multiplying by a negative number, you're going to change the direction of that inequality. So the first of our 4 examples, and I was standing in the way of, this is what I just basically verbalized, our first of 4 examples, algebraic examples, and the last one will be a word problem. We have x divided by 5 is equal to 2.3. Always like to include some decimals and fractions in my examples because that's what students tend to unfortunately struggle with the most. Now, when you're working with fractions and you're doing multiplication and division, you don't have to go through that nasty common denominator process, or you might think it's nasty. It certainly takes a little bit more work than with addition or subtraction. So this will go quicker than addition and subtraction. We don't need to find those common denominators. We have not an inequality. I intended on this to be less than, so let's change that. We have x over 5 is less than 2.3. The inequality is going to break up the left and right-hand side of these inequalities. I see on the left-hand side of the inequality, the less than symbol, we have a division of 5. And the inverse math operation of division is multiplication. So we're going to multiply both sides of the equation by 5 to undo that division of 5. And so this is going to, these inverse math operations are going to cancel out. You can also write that as 5 over 1 and do 5 times 1, and 1 times 5 is 5 over 5. And that cancels, of course, to be 1. So we have 1x. We are multiplying both sides of the multiplying both sides of the inequality by a positive number, so no need to change the direction of that inequality. We have 5 times 2 is going to be 10, and 5 times 0.3 is going to be 1.5, so 2.3 times 5 is going to be 11.5, and graphing that on a number line, we're going to put an open dot. I talked about this earlier in very meticulous detail about whether it's an open or closed dot. There's no equal sign, so we have an open dot on 11.5, so it's going to be between 11 and 12. And this unknown value of x is representing all values which are less than or smaller than 11.5. Well, smaller than on a number line is when you go to the left. Okay, so we have this shading to match this inequality. And if you want to check this answer, you can put 11.5 into this inequality and make sure that 11.5 makes the two sides match, just checking that critical value. And then if you shade to the left, you can put any number on the left-hand side into our original inequality, and it should give you a true statement. And we've shaded towards 0. 0 divided by 5 is 0, and that is, of course, less than 2.3. So our answer checks out. And I don't have to use this board, but I love breaking out my fancy picture-in-picture. So very high tech. I wanted to show you an example where we were dealing with multiplying both sides by a positive value and a negative one at the same time. Notice when multiplying by a negative number, both sides of the inequality, you are required to switch the direction of the inequality. So that means we have here in our second example, negative 3x is greater than 7. Well, we have our inequality breaking up the left and right hand side. Once again, I've put the variable on the left hand side of this inequality. We're going to get rid of this multiplication of negative 3 by dividing both sides by negative 3, and we get x. We have negative 7 over 3, but where's my orange at? Because we are dividing by that negative number, you must remember to change the direction of that inequality. And now we have x is less than negative 7.3, or excuse me, 7 over 3. Now that, I'm not exactly sure where that 7 over 3 goes on the number line, so 7 divided by 3, that's going to go 3, can put 2 3s into 7. Find a remainder of 1, and our mixed fraction is x is less than negative 2 and 1/3. Okay, well now I know where to put this number. I'm gonna put an open dot again in between negative 2. Let's see, here's 0, here's negative 1, here's negative 2 and 1/3. So if we look at breaking this interval up into 3 parts, we're going to put once again an open dot on that negative 2 and 1/3, and x is representing all values which are less than negative 2 and 1/3, and we again get smaller on the number line as we go to the left, and this is the shading on the number line that matches that inequality, which is a solution to our original problem. If we had a equal sign as a part of this problem, of course, we would remember that we need to shade in that point. Let's get on to our next two examples. Bye! Example 3. We have negative 3/7 x is greater than or equal to 9/14. Okay, so let's see here. We are going to need to recognize that in front of our variable, again on the left-hand side of the inequality, we have a multiplication of negative 3/7. You can take care of this division of 7 by multiplying both sides by 7, and then take care of that multiplication of negative 3 by dividing both sides by negative 3 in two separate steps. Or you can remember that when you're solving an equation and you have a fractional or a rational coefficient of your on your unknown, at least with a linear problem like this, where there's only one variable, you can multiply both sides of the inequality or equation, if you're doing an equation, by the reciprocal. So we're going to multiply both sides of this inequality and multiply it by, let's squeeze this in here, negative 7/3. And don't forget to put your parentheses around that, otherwise it'll look like you're writing subtraction. Okay, well, we have positive 21 from negative 7 times negative 3 over positive 21, and anytime you take a number and divide it by itself, it's going to cancel out to be 1, or 7 divided by 7 and 3 divided by 3 is equal to 1. So at any rate, you have just simply an x. Now over here, you have some cancellation that you really should do ahead of time if you're doing your math without the aid of a calculator. Very, very strong idea, suggestion, for you to do that. Both 7 and 14, both of these numbers have a common factor of 7. So 7 divided by 7 is equal to 1, and 14 divided by 7 is equal to 2. So we have some cancellation going on there. And then 9 and 3 also have some common factors. They're both divisible by 3. So 3 divided by 3 is equal to 1, and 9 divided by 3 is equal to 3. And again, you can do this kind of cancellation that I'm doing here across a multiplication sign. Never try and cancel across addition or subtraction or even division for that matter. You want to rewrite your division as multiplication first. So when you do that, I'm putting the blue chalk down, but that's what color my problem is in. We have 3 times negative 1. Probably should write that in there. So 3 times negative 1 is equal to negative 3. And then we have 2 times 1 is equal to 2. And you'll notice that I started to write something there in the middle. I'm kind of running out of colors already, so let me just highlight. We did multiply both sides of this inequality by a negative number. And when you do that, you need to make sure you change the direction of the inequality. A lot of students will say they know that, and then they forget it on the quiz. So we have x is less than or equal to negative 3/2, and that written as a mixed fraction, how many 2's will go into 3? Well, just one of them. So that means we're looking at x is less than or equal to negative 1, because there's only 1, 2, and 3, with the remainder of 1, so we're looking at negative 1 1/2. So we're going to put that closed dot on the negative 1 1/2, which of course is going to be in between negative 1 and negative 2. The unknown value of x, or this variable x, is representing all of the numbers equal to negative 1/2. That's why it's a solid dot, and the pointy side is towards the variable. So reading this left to right, we have less than. Well, where are all of the numbers on the number line smaller than negative 1/2 or less than negative 1/2? That would be to the right. And there we go. If you want to make sure this is right, you can take a value in your shaded region, plug it back into your original inequality, and make sure that the two sides are, that you get a true statement. And you can make sure that your dot is in the right spot by taking that negative 3/2 and plugging it back into the original inequality and making sure that the two sides match, even if there's not an equal sign as part of your inequality, just to make sure you found that correct critical value. And now we have 21 is greater than negative 6x. I mean, again, we're only doing one-step inequalities, and there's not as much work, thankfully, for dealing with multiplication and division as opposed to addition and subtraction, at least not when you're doing a lot of fractional examples like I am. Now here our variable is on the right-hand side. So you can leave the variable on the right-hand side, or if you feel comfortable with your variable always being on the left, you should practice it both ways, but you can rewrite this inequality flipping just everything around and keeping it like a big stamp. Like there's a big old stamp that says negative 6x. Well, negative 6x is on the right. I want to write it on the left. And thus we're going to take the 21 and move it over to the right-hand side. If you're doing this with an equation, you can flip-flop the two sides and not even think about it and continue. But if you're doing it with inequalities, make sure that you move around that inequality as well. Otherwise, you'll have a wrong answer. The open side is towards the 21. So when you swap the two sides around, please leave the open side still with the appropriate expressions. We have a multiplication of negative 6. The inverse math operation to multiplication is division. So we're going to divide both sides by negative 6, and we're going to get x. We're going to get... how many 6's go into 21? 6, 12, 18. Okay, so 3. 18 from 21 gives you a remainder of 3. So we have 3 and 3, 6. Of course, positive divided by negative is a negative answer. And 3 over 6 reduces to be 1/2. Both 3 and 6 have a common factor of 3. And so this is our answer in reduced form. And let's make sure that we don't forget we divided both sides by a negative number, so we switch the direction of that inequality symbol. Open dot on negative 3 and 1/2. So again, I'm also working with a lot of negatives, trying to think of where my students make mistakes when they're first starting off in their journey of algebra. So between, let's see, negative 3 and 1/2. So between negative 3 and negative 4, we're going to put an open dot. This value of x is representing all values which are open side greater than negative 3. And greater than, you get larger as you go to the right on the number line. Probably sound like a broken record now, but again, just trying to help you get that into your brain. Remember it. A song download costs $1.29 on a popular online store that allows you to buy music. How many songs can be purchased if you're given or maybe buy a $20 gift card? Well, how do you figure out the cost of anything you buy at the register? They're going to take the number of items you buy, and let's see here. Buy one song, $1.29, and buy another song, another $1.29. Buy another song, another $1.29, and those are going to keep adding up to make up my total cost. Well, repeated addition is multiplication. So your cost, you have some money in your pocket, at least in terms of in the form of a gift card. This is how much total you can spend, and the cost, your total bill for all these song downloads is going to be $1.29 times the number of songs that you buy, which I like to write often in word problems, just the whole word as opposed to an X or a Y. And you might even write number of songs here. And how is that bill going to need to compare to how much the value of the gift card? Well, you can't spend $25 if you only have $20 to spend. Your bill has to be what? Exactly equal to 20 or less than. So our inequality is 129 times the number of songs is less than or equal to $20. Well, again, we have our variable being multiplied by a number, and we want to solve for the number of songs. We want to undo that multiplication of 1.29. So we're going to divide both sides of the, I guess I'll just do it in white, divide both sides of the inequality by 1.29. And the number of songs, let's put it over here, is going to be less than or equal to, right off the top of my head, 20 divided by 1.29 is going to be 15.5. Okay, well, what are you going to do? Say, I want just 38 seconds of that song, or a minute 27 seconds of that song when it's a 3-minute song? No, you have to buy an entire song. So you can't buy 15.5. In the context of this word problem, the final answer is you can download, I'm going to write just buy though because I'm running out of space, up to 15 or 16. 16 is going to take you over the $20. So you can buy up to 15 songs. Now, my inequality here, let me go ahead and put that x equals songs. That is the algebraic, sort of pure algebra answer to this problem. But the fact that you are purchasing songs, that would not make any sense. We can't purchase a decimal number of songs. You've been seeing me with all of these problems putting a dot, whether it's closed or open, on my critical value and just running an arrow, right, forever. Well, if I start at 15.5 and I run to the left because it's x is less than, that would start to indicate that I could buy a negative number of songs. So really, my inequality here is going to be x is less than or equal to 15 and greater than equal to 0, and x can only be a whole number. So on a number line, we're looking at a dot on 0, 1, 2, 3, 4, 5, 6, 7, 8. These are all supposed to be closed, of course. Just trying to hurry because you don't need to stare at me watching, making me make a bunch of dots and stutter. Excuse me. So that's what the graph on the number line is going to look like. If x is greater than 4, then, okay, let's see here. I've maybe put a few too many boxes in here, but I'm trying to represent this inequality, like what kind of inequality is going to go in this rectangle. What would the new inequality look like if I want to start with x is greater than 4 and end up with some kind of inequality where the right-hand side is equal to negative 12? Well, what do you multiply 4 by to make it equal negative 12? You have to multiply it by negative 3, right? So I need to take this inequality to match this sort of partial pattern, multiply both sides by negative 3, and when I multiply both sides by negative 3, I need to remember to change the direction of that inequality. So we're going to have, if x is greater than 4, then negative 3x is got to be less than, just less than negative 12. And that is the end of my last example. Got a little bonus there because I kept saying we're going to have 5 examples, but instead you got 6. I'm Mr. True. Go do your homework.